Hi good people, Titus here again for part 4 of our camera system prototype series. In the last video we created a collision event to trigger the camera tracking of our player character's position. And in this video we're going to expand that code to include some blueprint interfaces to trigger an alarm state in the game that will change multiple objects differently. Confused yet? Don't worry, we'll jump right into it and I'll kind of show you what I mean. To get started, I'm going to be creating different elements in the game. If you remember before, we imported a mesh for our security flash, well, it's called flashing alarm light. But I'm also going to go back to the original Epic Marketplace and import another asset. It's going to be the door. So that was this guy here. And this project is available on the Epic Marketplace for free. I think it's just called Blueprint Project. And I'm going to be stealing this little door right here. So it's going to be the same process. You just find the asset, select it, right click, asset actions, and then you can migrate. Just leave everything checked and then choose the location, which for me is going to be in my documents folder. And this is our project here. Content and done. And do yes to all because we have some shared materials from the other things we imported. Okay, we can close that out now, and now you can see our door. Okay, so let's create some more blueprints. The first thing we'll do is we'll set up our blueprint interface. So we'll right click, blueprint, and there's blueprint interface. I'm gonna call it BPI alarm. I'm gonna open that up here. I'm gonna create, I guess, two functions. Alarm triggered, or maybe alarm state. Make it simple. And I'm gonna create another one, and we'll call it all clear. So those would be my two, at least initial functions that I'll make. I'll probably expand that a little bit later. We can dock this up here. So now with that blueprint interface, we can use that to trigger an event and change multiple blueprint objects in our level. So we need to get some more objects because we don't have that. Actually, right now we only have the camera. So we'll create a new blueprint. I'm going to make it an actor type. Call it BP, I guess, light. Yeah, we'll do it alarm light. And if we double click that one, I'm going to add a static mesh. I'm going to call this just the light. And then I imported that in the beginning of the series. It was this flashing alarm, and it's just this guy. I'm going to add a light component, so I think I'll do a rect light, so I can rotate it. So rect light here. And then I'm just going to move this kind of dead center, I think. Maybe right there is probably good. I wonder if I should move it higher. Yeah, we'll just move it right there for now. So now there is a movement component you can add to your object called, I think it's rotation. Because I want that thing to kind of spin around. Yeah, rotating movement. If you put that on in your components list and simulate, and unfortunately it rotates the whole thing, and I kind of only want to rotate the light, so I'm not going to be able to use that. So I'll just delete the rotating movement there, and then we'll just do that kind of in code. So at the begin play, we'll basically get a reference to the light's rotation, and then we'll just maybe add 1 or 2 degrees and then update it and then kind of rotate it. Well, actually we'll do that in tick. We'll do it every frame. So we'll create a quick variable. We'll call it rotation. Rotations are degrees, so those should be floats. My initial is going to be 1 degree. I will get a reference to it, and then I will get a set. And then we're simply going to get a reference to our light. And then off of our light, we will set relative rotation. We're going to have to right click and split this pin. and I'm going to rotate around the Z-axis just to get it to spin around. So I can hook up this, and then what we can do here is do a addition. We'll add 2 degrees. So we'll get current rotation, which is 1. We'll add 2 degrees. Set that to our rotation, and then we will also set that to our new value for our rotation. And so the next time it gets called, you know, it'll be 1 plus 2 is 3, so it'll pull 3 and add 2 and be 5, and then kind of continue on every frame here. So if we were, I don't think I can simulate that, can I? No, I can't. Oh wait, no, yeah, I can actually. I got the wrong reference. So I delete the light. I want the rect light. And then put that in there. There we go. And then if I hit simulate, now it's just the light that changes, which is exactly what I want. Now for the rect light, I'm just gonna make it a kind of green color, because I'm gonna change that to a red when the alarm state's triggered. So now when I simulate, you got the rect light just spinning around, but the base is stationary, so that's the effect that I want. So let's add this in map so we can get a good look at it. Place it there, go and rotate it 90 degrees. And yeah, it looks pretty good. Maybe move it over a little bit. And there you go. So now we got a light. Now we just need to get some code to actually get it to use the blueprint interface. So we'll go back into our alarm light. Before we can actually reference the BPI alarm interface, you'll notice if I like try to do the functions that we created were alarm state and all clear. So if I try to do like event, alarm state, or what have you, it's not going to show up. That's because you got to go into the class settings, and you actually have to add the interface on the right panel here. So you can search for your, you know, whatever you called it. In our case, BPI alarm. And then you'll notice over here we have an interface section that showed up. And now we can actually reference the functions, but we can't call the events until we compile. So we'll compile and save. And now I can simply right click and do an event alarm state. So when the alarm is called, I'm going to get a reference to the light. I'm going to set the color, and the color I'm going to set is going to be a red. And then I can get a reference to the all clear. When the all clear is called, we can use the same reference to the light. And I'm gonna move it back to green. I don't remember what color green I used, so I'm gonna go back to my viewport, select the light, bring that open, and just copy the hex value. And then I can just paste in the hex value that way. Nothing's gonna happen though, because we set up the blueprint interface. We define the call functions, we define the logic in the call, but we never actually make the call. So that's why it's not changing to red. So to do that, we need to do it in the appropriate spot. You can do it from any blueprint, but we already have a blueprint set up that's going to be handling the logic of capturing the player, and that's the overlap event. So it makes kind of the most sense to kind of put it there. But you can technically put it anywhere, so you know, either way. The way you call the function is we'll do it on both the overlap and the begin overlap and the end overlap. We'll pull off here and we'll do a get all actors with interface, and then you can search for the interface you called it, which is BPI alarm for us. And now this will go through the entire array of items that have this interface. So you know, you can have many different items. So we're going to use a for each loop. If you had a specific one that you want to reference, you can do that, but if you don't know, you might as well just cycle through all of them and execute whatever code you have the logic set up to do. If you don't want the logic to run, put it under a different function name or call it from a different interface, right? So you can do it from a lot of different ways, I guess. And then from here, we can call out the alarm state, which I believe is what we called it, right? Yeah, alarm state. So now you'll probably see two of them, or you might see two of them. Make sure you select the one that has the message hyphen, because that way it'll message all the other instances as well, not just this one. If you choose the one without the message, it just does this own blueprint. So, I mean, I guess you could, there's probably edge cases where you'd only want it to run on one, but in those edge cases, I mean, you might as well just set up the function to run in the blueprint directly rather than through an interface. But it is available to you, I guess, if you wanted to do that. And then we'll hook up our array element into our target. And what we're going to do is basically copy that code and paste it for the end overlap. But the difference being is for the alarm state, we'll call the all clear. So now anything with the code will actually get run. So now basically our little light should work. And you can see it's red. If we move off, it's green. Now, just for good practice too, even though we already have it set up, we can technically call, you know, our light code into the interface code as well. So like if you wanted to, you can right click and do event alarm. Well, actually, notice it's not coming up, and that's because we actually haven't set up the class settings. So we'll go to class settings, and you see there's no interface on the left-hand side either. So we'll add the BPI alarm. The interface shows up. If we go for the event now, it's still not going to show up, and that's because we haven't compiled. And if you search now, it shows up. So we can do the alarm state and the all clear. And if you just wanted to match code our spotlight function here, we can grab that, because our code could actually get longer based on this alarm state. So we can kind of shorten this up a bit and kind of split it out and organize it a little bit better. Doesn't really matter, I guess, but it just shows you have a lot of flexibility when it comes to setting up your code. So you don't always have to do everything a certain way. Kind of like programming is just problem solving, right? A lot of different ways to approach a problem. And now this code will work perfectly fine, just like we had it, except the interface is now controlling the camera light and the alarm light there. Which is good. That's kind of what we wanted. Now, just for one other object, let's go ahead and make a door. So like if you wanted the functionality where like the alarm state is triggered, it closes the door. When the alarm state is released, the door opens, something like that. We can do that with the same interface. So let's create another blueprint class. BP door, we'll call this one right. And then I'm going to add a static mesh, door right. And then if I search door, it's the swing door. Now, you could set up both doors in the same blueprint. Just for ease of use, I'm going to make two different blueprints because I want to control. I only want to deal with one pivot point, and it's easier moving around just this one. Basically, it's easier to move two different blueprints around two different pivot points than it is trying to calculate the math for two separate objects on the same pivot point. But you could technically do it both ways. This is going to be easier for me for right now. So BP underscore door and left. And we will add our static mesh, door left, and same swing door. So now we need to figure out, so this one's gonna be on the left, so that seems right because the hinge is here, but the one on the right, this should be on the right side because I'm gonna be referencing it while looking at it. So let's flip this 180. Yeah, like that. That way our pivot point's still on the edge there, and I think that'll work just fine for me. Okay, so we got that saved, and we got that one set up. Okay, so now if we go in our scene, we'll drag out our left door, and we have to rotate it, so I'm gonna rotate it on its hinge. There, and then the right door, rotate it on its hinge. Nope, it's the wrong way. I gotta go this way. All right, so now I want to start with the door open. So I'm going to put in another door here just for reference so I get the length right. So this is going to be probably a little boring just watching me mess with these values here, but bear with me. All right, so let's set this in here. That looks good. And then we'll just snug this one up over here. And then we'll just delete this guy for our reference. So, okay. So now the right door, oops, is this one, and the left door is going to be this one. So when the alarm state triggers, we want to affect the location and pull it left. So we're going to be moving, I believe that's the x-axis there. So we're moving the x-axis negative, and on this one, we're going to be moving the x-axis positive. So let's do the right door first. We'll go into our event graph, and we want to do it off our interface. So let's actually go to class settings, add our interface into the blueprint, compile, and now under event alarm state, and under event all clear, let's go ahead and prep that. We will get a reference to our door, and we'll do set relative location. And this is probably going to be a bit tricky, but the way I'm kind of doing it here, let's hook up these pins. So we're on the, I think the door is 75, the float value 75 units apart. So I'm going to be moving this door negative 75 to bring it closed. Well, the door is 150, so I'm going to move this one 75, and I'm going to move this one 75 to get the whole width, basically. So you would think that I would move this, well, maybe it was confusing for me, but if you move it negative 75 degrees here, the way my brain works is I would tell it to then do positive 75. But that's not actually right. So you would actually set this to 0 because it's a relative location. So the current location, or the way it reads this this function, is 0 is its original position. So you're subtracting 75, and then rather adding 75 to that position to bring it back to 0, you just tell it to go back to 0, and it will. And let's see if I am right on the one door. So it should shimmy and then shimmy out, just like that. And now let's get the other door. So we'll do the left door. Again, we have to go into the class settings. We'll add our BPI interface, compile, and we will do our event alarm state. event all clear. We'll then get a reference to our door, and then we will set the relative location. And you could set, like, you could do it world location too. It's just tricky because you need to know exactly where the door is and then move it off there. There's a lot of different ways you could do this, so you know, no right or wrong answer. Now for this one, you're going to be moving in the X in the positive, so you think of it as like a Cartesian grid. So the right is positive X values, so we'll move it 75 positive, and then we'll move it back to 0. So just 75 there, 0 there, and that should give us some basic functionality here. So let's try that out. Hey, that looks pretty good. Pretty cool. All right. Now, if you don't like the speed, there's another way you can approach this too. You can use a timeline, and I can show you what that looks like. So just real quick, let's bring this down, this over, and we'll drag off here, and we will create a timeline, and we'll call this door swing. If we go into the timeline, let's do it across just 2 seconds. We're not going to do a super long opening. The value we're modifying is technically a vector, but we're only modifying one value in that vector, so we can get away with doing just a float in our timeline. So we're going to add a float track, and I'm going to call this the X movement. And I'm just going to have 2 values. So I'm going to add a keyframe at 0. I want it to be 0. My second keyframe is going to be at 2 seconds. I want it to be -75. Voila. And I got that value from what I'm actually swinging over here, right? And you can see our X movement shows up now. So now all I have to do is right click and split this struct pin, and then I can just drag that in there, and then that's pretty much good to go. Now what's interesting about this method is you don't need a secondary relative location because you're using timeline, so you can actually delete it. You can move this up here, and you can just tell it to reverse on the all clear. And we're only doing one door, so it's gonna look a little funky, but you'll at least see it's a nice smooth open and close. So let's repeat the steps over for this guy. So we will delete the bottom part, drag this guy out here, we'll add a timeline, call it door swing, and this time we're going into, instead of -75, we're going 75. So we'll add a float track, call it X movement, or whatever you want to name it, doesn't matter. I'm only going to do 2 seconds. I'm going to add 2 keyframes, one at 0, 0, and one at 275, I think it was. There's our graph, pretty simple. And now our X movement, I can split this struct pin, pop this into there, move this up and plug this into reverse, and you got very simple code. And now with the power of blueprint interfaces, you can get some really cool logic going. And our render target is still working, our render texture. Yeah. All right, so yeah, with I love BPI interfaces. I think they're really cool. So it's a good way to modify multiple objects in your your level, or whatever project you're doing in, and you can execute different code just by the same trigger. So I think that's really awesome and really handy. Yeah, I think we'll cut it here, and we'll expand our camera system in the next video. I think we'll add a camera's perspective change on our player character, so we can aim and shoot the camera, and then maybe disable it. So keep an eye out for that one. But yeah, hope you enjoyed the video. As always, thanks for watching, and we'll see you on the next one.